haw, hee hee haw. Oh, I mean e-learning. It's been 5 weeks since our quarantine started, and came the day we had to stay home. And your kind smile I've missed since we parted, but you miss my tie flips 1,000 times more. Where, oh where are you today? Why did you leave me here all alone? I searched the world over and thought I found students, but they closed the schools and we was home. Happy Friday, everybody. I got myself cleaned up. That was the first time I've ever had a pie in my face. And I tell you, you know what the worst thing about having a pie in your face is? It never ends. 3.14152653589793238462643384626433832795028. And it goes on and on and on. In fact, on Monday, when I was driving into school, we can only go into school, the teachers, for a few hours on Monday. When I was driving into school, there wasn't hardly anybody on the road, but I noticed that the police officer pulled Mr. Pie over. And then I thought to myself, I guess Mr. Pie, he doesn't know when to stop. So, hopefully you enjoyed that. And so it is Friday. For those of you in math counts or want to do an online competition, we have one this morning at 11 a.m. It will take a half hour max out of your time. It starts immediately at 11. And so we are in the Elite 8 in the country. And last week was quite a barn burner. I was stressed out. I was turning my hair gray. But we need you and we need your score. And so here's the bracket. We're going against Indian Valley, I think, Eagles of Harleysville, Pennsylvania. The population, I have no idea. But it could be a tough one. And if we win, if you see the bracket, we're going to be in the Final Four. And that will be next week. And I don't know if my heart can take this much more. But you guys are doing a great job. And it makes a little fun and excitement to be in the big dance. And so make sure, if you want to be a part of that and you've never done it before, I will send you a username and password. And you just click on this on our school page. Just click on Online Math Counts Competition Day. You're all invited. Click on that, and we're glad to have you. So, the attendance form is right here. Make sure you are completing that. This week's attendance closes out on Sunday night. Monday morning, we will have next week's attendance. You need to finish the attendance for this week before Sunday night. Every once in a while, someone goes, I can't take attendance for last week. That was last week. This is this week, so make sure you get that done. So right now, pause the video, take this attendance before you forget, and then we'll get right back to you. So get the attendance taken. Now that you got the attendance taken, let's see what we have in store for today for algebra. And so we'll scroll right down here. One thing part of class, is we have our warm-ups. Some of you did not do this week's. There are 3 every week on Khan Academy. You need to get those done. You need to get them done today. And so, or tomorrow, but get those done before the Monday, and so we can move on before Sunday night. Also, normally in class, after we do our warm-ups, we take questions on homework. I sent out an email over last class. There was some discussion. I didn't go into deep discussion on some of the harder problems. We did want to introduce you to a couple of them, but the one problem on the homework, the reason when we have a negative 1/2, and we would put that in the synthetic division, is because you're like pulling a 2 out of that, and it's really 2 times quantity x plus 1/2. So what you're doing is you do the synthetic division by putting the negative 1/2 in the corner, but you also need to divide by 2, and that's why we cut those coefficients in front. And on the notes, I divided by this first and then said to divide by 2, but then that messes up the remainder, and you don't want to divide the remainder by 2. But if you would divide the polynomial by 2 first and then do the synthetic division with negative 1/2, then the remainder works out perfect. But you can do it either way. You just have to remember, don't divide the remainder by 2 if you're doing the negative 1/2 first. And so those are little things that we lose when we are in class. And so the phone's ringing, and I hope someone gets it. And so, on that. Okay. So, little discussions we do miss out on, but feel free to email me, especially on the homework, and make sure you're showing good work. We look at your work and then try to figure out your thinking, and so I want to see it. And then let me know. And some of you are doing a great job of emailing me questions. And so that was a little homework thing, and I can always type that out and show you things, and we can discuss them. But today we're going to do a little review and kind of connect negative exponents to the fractions and the algebraic fractions. And so hopefully you find this to be an easier day. You see the homework is page 333, 2 to 58 even. Make sure you copy the problem. They're all short, and that's why you have 29 of them. And then write the answers. And so we'll get you started on that also, and maybe even do a few harder ones together. And so, but this is notes number, well, let's see here. What notes number was it? And so it's notes number 117. And so notes number 117, we're going to talk about simplifying problems that have negative exponents in them. And so notes number 117. And so we'll do a few review problems at the beginning, just to get everybody's mind going, and then we'll go from there. So, few review problems with exponents. Cody, d to the 11th times d to the 5th. When we multiply like bases, we add the exponents. Great job. So that's going to be d to the 16th. We'll go down. Number 2, 2y cubed times 4y to the 6th. What one's that going to be? Logan? Do we add both the numbers? Multiply both? Oh, we only add the exponents. So 2 times 4 is 8. And then we add the exponents. So it's going to be 8y to the 9th. Great job. Number 3. What is 2x cubed? What's it going to be? Colin? 6x cubed? Colin. 2x. When I was in 7th grade, my teacher always said, don't say quantity of 2x cubed. Say the 2x taken 3 times. I'm just teasing with you, Colin. So 2x times 2x times 2x. Remember, that is not 6x cubed. It is 8x cubed because we're cubing the 2. Number 4. What is m to the 5th to the 4th? What would that be, Aiden? Yes. A power to a power you multiply. Woohoo! And so that's going to be m to the 20th. Jordan, what's number 5? Anything to the 0 power equals 1. Woohoo! Now, at number 6, when we divide like bases, what do we do, Ethan? We subtract. Great job. Oh, not this one. 1 over 3 squared quantity cubed. Well, you're going to notice on tonight's homework, there's a lot of ways you can do them. You could say 1 over 9, because that's what 3 squared is, and then you could cube it. Well, what's 1/9 times 1/9 times 1/9, or what's 1 cubed over 9 cubed? Lauren, what would it be? 1 cubed? 1. Good job. And 9 cubed? Do we need another quiz over the cubes? And that would be 729. So it's 1 over 729. Great job. And then here, when we divide like bases, we subtract. And so you would get x to the negative 6th. But you would also, if you were canceling, where would those 6 extras x's be? Would they be upstairs or would they be downstairs? What would it be? Abby? They'd be downstairs. And so this would be x to the 6th downstairs, and that's over 1. And so what we're going to focus in on today, what we did in pre-algebra last year, just trying to refresh your memory and then connecting it to these algebraic fractions, is that when we think of a negative exponent, you do not think of a negative number. You have to have a negative base, and even then it's not, the answer isn't always going to be negative. A negative exponent just means, woo, the inverse, the reciprocal, the reflipical. And so you just got to keep that in mind as we're going through the problems. And you don't have to do the problems exactly like I did. but I need to see. I'm not with you. I can't see what your brain's doing. Maybe you're just doing picture math or mathway or whatever. And then I don't know if I can trust you. And so I need to see work so I can give you a grade. And so I don't want to give mathway a grade or picture math or picture pages or whatever else. And so we want to make sure we have that. And so what we're going to do is the definition of a to the negative n power, or the opposite of n, as correctly said. If a is a non-zero real number and n is a positive integer, then a, so if n is a positive integer, then we can say negative n. And so a to the negative n really equals 1 over a to the positive n. And so we're going to talk through a few examples, and we'll also review a few properties of exponents. Okay? And so if we move myself over here to this corner, whoa, get the sound bar off my face. There we go. We're back. Remember the exponent rules. All the high school teachers love it if you always remembered all of these. And these are not necessarily rules. They're just properties, and you understand them. When you multiply like bases, you add the exponents. So you write b to the m plus n. A power to a power you multiply. So that's b to the mn. When we have a fraction to a power, it's like taking the numerator to the power and the denominator to the power. And when you divide like bases, what you going to do with those exponents, Cam? We're going to subtract them. You betcha. And so that's going to be m minus n. And so all those properties that you need to use on your homework, when I got to know when to add them, know when to subtract them, know when to multiply, know when to divide. You got to keep track. And so if you understand it, you don't have to memorize it. You internalize it. I think somebody said that one time. And so we have that. So we got all these things. And let's do a few problems together. Let's do some of these problems together. And so here we go. Rosie, what's 4 to the negative 3? Is it negative 64 or is it 1 over 64? Good job, Rosie. It's 1 over 4 cubed, which then is 1 over 64. So remember, a negative exponent does not make the answer negative. It might be, but that will be because of the base. This next one, I have no idea what 5 to the 7th is. And I don't really want to put it over and then 1 over 5 to the 9th and figure out what that is. I don't know what those numbers are. But when we multiply like bases, Danielle, we add the exponents. And so this is going to be 5. 7 plus negative 9, Danielle, is negative 2. Excellent. And so 5 to the negative 2 power, Jordan, is 1 over 25. Great job. Number 3. Couple ways you could do these. When you're doing your homework tonight, you could say, well, I could simplify this, and this would become 1 over 12. And then I have to take 1 over 12 to the negative 2 power. But that's the more difficult way of doing it. The easier way is a power to a power you, Jack, multiply. And a negative times a negative is a positive. And so this would be 12 squared. And 12 squared is 144. I can't believe I'm writing 144. That's so gross. You know, dozen is a gross. This answer is gross. And so there you go. Now number 4, this is one people are going to have trouble with. Because on number 4, when you just see a 4, what exponent is really there? Is it 4 to the 0? Is it 4 to the first? Madison? It's 4 to the first. Great job. And so I have 4 to the first over 4 to the negative 3. Now, if you just remember that when you divide like bases, you can subtract the exponents, which would be 4. And then you would have 1 minus negative 3. So does that give you a 2, a negative 2, a 4, or a negative 4? What would it be, Cole? It'd be a 4. So this is 4 to the 4th. And 4 to the 4th is 4 squared squared. And so 16 squared, what would that be? Elijah? 16 squared. Yes, 256. I hope you still know that. And so we're going to come and give you some quizzes next fall. And so make sure you're ready. Otherwise, a student could say, well, this 4 to the negative 3, if it goes upstairs, the reciprocal of it, it would just be 4 to the 3rd upstairs times 4 to the 1st, and then 3 plus 1 is 4. That's another way of thinking about it. Problem number 5. When you multiply like bases, you, Dominic, add the exponents. So that's 8 to the 1st. Then we have it 8 to the 4th on the bottom. And if I got 1 8 on top and 4 8s on the bottom, we have 3 8s on the bottom. We have 8 cubed. And you could subtract them. But I thought 1 minus 4 was negative 3. Well, that's if it's on top. It would be a negative 3. But if you're just canceling, 8 to the negative 3 is 1 over 8 cubed. So yes, and 8 cubed is, what is it? Hannah? 512. Great job. Let's go to number 6. It's down here in the corner. When you're simplifying this, first of all, anything to the 0 power equals 1. So why even write that down? Do you think the book's going to try to trick me, have some big ugly thing to the 0, and then it's just like, wait, the answer is 1. Oh, I think I got it. And so you see part of it, that just part's 1. So really this problem is 2 to the 1st over 2 to the negative 2 all to the negative 2. Now you can use your properties of exponents and simplify this if you wanted to. 1 minus negative 2 is 3. 3 times negative 2 is negative 6. And 1 over 2 to the 6th is 1 over 64. And you can do all that. Or you can say this is 2 divided by 1/4. Because that's what 2 to the negative 2 is. And that's all to the negative 2. And when we did complex fractions the other day, to divide is to multiply by the reciprocal. So 2 divided by 1/4 is 8. And 8 to the negative 2 is 1 over 64. Great job. And so there are multiple ways to do it. But I want to see how you are solving them. So make sure you show me your work. So I go, oh yeah, they're using the properties of the exponents. Oh yeah, but she's writing them out and simplifying the individual parts. Oh yeah, I see how you're thinking. I want to see it. So make sure you show me none of this. Problem, answer, problem, answer. That's okay for the first few. That's okay maybe for the first half. But it's not okay for the last ones. And don't act like the last ones are like the first ones. The last ones are much harder. You know it, I know it, and we're watching. And so make sure that you're showing work on those. Now, for the last couple, right here. Ooh, I forgot. 7 and 8. There is no property when there's a plus sign for you to add or subtract them. So you would just have to do 1/3 plus 1/9. There's no shortcut 3 to the negative 3 or anything. And so 1/3 is really 3/9, and 3/9 plus 1/9 is really 4/9. And you don't really have any of those on your homework, but you might. There might be a part where it's like, wait, there's no property here. I can't just take a shortcut. You look up here in these properties, and adding bases is not one of them. Multiplying bases, dividing bases, a power to a power, those are. But adding bases is not a property. But here we're multiplying the bases. So if you wanted to write this out and do 1/3 times 9, you could. And 1/3 times 9, 1/3 of 9 is, what would it be, Abigail? 1/3 of 9 is 3, great job. but then this is all to the negative 2 power. And so 3 to the negative 2 power is 1/9. But see, on this problem, you could use the shortcut. When you multiply like bases, you add them to negative 2, and then you got a power to a power you multiply. And that'd be that, and then 3 to the negative 2 is 1/9. And look, I arrived at the same answer. And so you start walking your way, I start walking mine, and we meet in the middle. I know those words aren't quite right, but it was close. And so you make sure you show your work. And then why are we talking about that when we're doing algebraic rational expressions? Look at problem 9. What is x to the negative 3? What is x to the negative 2? X to the negative 1. And see, this is a more advanced way of writing 1 over x cubed. Now, a lot of people are going to write the next two wrong because they're going to put the 2 in the denominator. But there's no parentheses, so the 2 stays up in the numerator. And so this is really 1 over x cubed plus 2 over x squared, and then plus 3 over x. Right, like that. And so then it looks like problems we've done. And so it's like, okay, if I'm adding fractions, I need to find a common denominator. My common denominator is going to be x cubed. So this guy needs nothing. He stays a 1. The middle guy needs an x. 2 times x, 2x. Oh, my exes live in Texas. Well, hopefully not. Hopefully some of your exes live in this problem. That's why I hang my hat in Tennessee. And this last problem, you got to multiply top and bottom by x squared. And so when you do that, you get 3x squared. And those don't add together. And so I combine my knowledge of negative exponents with what we're doing, and we get this. And for this very last problem, I'm going to go sit in this corner here. Oh, we'll sit up here and get out of the writing. And so when we look at this one, this a to the negative 1 is really 1 over a. This is really 1 over x. This is really 1 over a squared. And this is really 1 over x squared. Now, what could we do? We could do quite a few things. We could just make this a group, and we could factor the bottom if you wanted to. The bottom's going to factor into 1 over a minus 1 over x, because it's a difference of squares, even though don't let those fractions stress you out. And this would be 1 over a plus 1 over x. And the top is 1 over a minus 1 over x. And these guys will cancel. But don't think your answer is 1 over a plus 1 over x, because that is in the denominator. And so doing it this way seemed like it was a cool method for about half a second. And then when you find the common denominator here of ax, this would be x plus a. And if you got 1 divided by x plus a over ax, all you do is flip the bottom and your answer is ax, the product, over the sum. And there's your answer. Now this would have been much easier if way back here we would have just multiplied the top and bottom by the common denominator. If you would have multiplied by a squared x squared, you say, well, what would you get? Well, on top you'd get ax squared, because the a's would cancel. And then you get a squared x. Sorry, those don't look very good. And on the bottom, the a squareds would cancel, and you get x squared. Then the x squareds would cancel, and you would get. ax out of the top. And then you are left with x minus a. And then on the bottom, you factor that, and you get x plus a times x minus a. And then those x minus a's would cancel. And you'd still be left with ax over x plus a. So I didn't circle that very good, but you still get the same answer. So if you ask me, you can decide whichever way you want to do it. But that'd be a hard problem. I don't even think you have any of that hard tonight. So get your piece of paper out, get your book open. I'll give you a second, and then we're going to start the homework, okay? So get your paper out and let's get going. Got their paper out. Everybody have their book. You didn't leave it in your locker. Make sure you got it. Remember, we're only doing the evens. So evens to problem 58. Evens. See, I'm not pressed and accidentally doing an odd one. And so we're going to start. Copy the problem. These first ones go fast. 4 to the negative 1. Erica, what would that be? 1/4. Great job. 2 to the negative 2. Erica, just say the same thing. Oh, 1/4. Great job. And so that's going to be 2 to the negative 2. And then 8 to the negative. You can do these first ones. When you get to problem 26, 5 over 4 to the negative 2. Lots of ways you can do it. Just remember, the negative means the inverse or the reciprocal. That just means flip it. And so that'd be 4/5. And then you still have to square it. You square the top. You square the bottom. So anytime you have a fraction to a negative power, you flip it and you square it or cube it or whatever. Same thing on 28. 7/6 to the negative 1. Just flip it over and you got it. Then, when we get to the second page, problem 30, problem 32. This is where I was talking about where you don't have the properties. 30, the whole thing is to the negative 2 power. That's part A. You got to answer that. Part B, only the 5 is to the negative 2 power. And you're going to show me what's the difference in the answers. For problem 32, oh yeah, there's no property for a plus sign. You just have to say, what's 2 plus 1/3? Well, that'd be 2 1/3. But we don't like mixed numbers. We'd rather write 7/3 if you want to write it highlighter. And then you still have that to the negative 2 power, I believe. But on B, you can, well, they're not like bases. So what's 2 times 3 to the negative 1? Here, we'll get it off a highlighter. Well, that'd be 2 times 1/3, which would be 2/3 to the negative 2 power. Don't stress out about problem 34. It says, suppose you didn't know is b to the 0 equals 1. But I already know it. How can I unknow something I already know? That's kind of hard. And so how would you simplify it? All you do is say, add the exponents. Not too tough. Okay? And then the harder ones here for the second part of the assignment, and we're just going to problem 58. These have the variables in them. And so the ones people are going to miss, 36 people will miss. Because the negative 3 is the only thing, or the n to the negative 3rd power is the only thing negative 3rd power. So in problem 36, it's really 2 times 1 over n cubed. So your answer isn't going to have an 8 in it, and it's not going to have 1/8 in it. It's just 2 over n cubed. And I can tell who's not watching the videos to the end because you're going to miss this problem. And I showed you correctly how to do it. And so it's 2 over n cubed. 38, the whole thing is to the negative 2 power. 40, just write it as fractions. 42, a power to a power. 44, add them. 46, you're squaring everything, and 4 squared is not 8. And then here, 48's a toughie, because only this is to the negative 2 power, not the 3. Make sure we don't get the 3 in. Maybe I should highlight it. Only this is to the negative 2 power, but here the whole thing is to the negative 1 power. Ooh. And then the last ones, they should all be good. And then send it to me. Don't wait till Monday. Don't wait till Sunday night. Just get it done on Friday. Send it right away, and I'll try to get Power School updated. And so write the problem, write the answer. For some of them, like some of these last ones, you could just write the answer on a couple of them. But like 48 and some of those in the middle, there's a little work to show. So make sure you do that. Okay? So we really enjoyed being able to teach you this week, even though we're all not together. So email me. Let me know how it's going. And do the contest, 11 a.m. this morning. We need you. We could go to the Final Four. But whether we do or not, we're very proud of all of you, and we appreciate all the work you're putting in. And so, hey, we'll see you later. Until another episode of Hee Haw or whatever else we come up with. So, enjoy. Have a great day.